Good morning, afternoon, or evening, cats and dogs. This is our last video of the school year, and we're going to be talking about slope. So let's get right to it. Slope, which we mentioned in the previous couple of lessons, describes the steepness of a line. It also represents a constant rate of change. If we have a line that's curved or zigzag, that doesn't have a constant rate of change, but a line does. We also define it as rise over run when we're looking at a graph, which is our vertical change over our horizontal change. So vertical is up or down, hence our rise, and horizontal change is left to right, which is why we call it the run, so left to right. We also define the slope as passing through any 2 points, and it's defined as the variable m. We use m to represent slope. Our 2 points are x sub 1 and y sub 1. That's our first point, hence the little ones. And then x sub 2, y sub 2, that's our second point. So we have our slope m being y sub 2 minus y sub 1. What that really means is you're subtracting the y coordinates over x sub 2 minus x sub 1. Again, subtracting the x coordinates. So we subtract the y's, we put that on top, we subtract the x's, we put that on the bottom. So it's going to be the difference of the y coordinates, because that's how far up or down we go, over the difference of the x coordinates. Now, we'll talk a little bit about that as we get into finding the slope between any 2 points. We'll also talk about looking at slope graphically. So let's just start with a couple of problems. Number 1 says to find the slope of a road that rises 25 feet for every horizontal change of 80 feet. Since slope is defined as rise over run, or vertical change over horizontal change, our vertical change is 25 feet, so that's going to go on top. Our horizontal change is 80 feet, so we'll put 25 over 80, and we can simplify that. We can use our calculators to simplify it. That gets us 5/16. If I take 5 divided by 16, that gets me 0.3125, which is about 31%. One of the times you might actually see something like this is when you see a pretty steep hill coming up, whether you're going up or down that hill. It might grade that hill as a certain percentage. It might say this is a 5% grade or a 12% grade or something similar to that. We also grade hills, for example, like when I do runs, my Garmin will tell me what percent grade that hill is or how steep that hill is. So we're really talking about the slope of that road. So this is just one example. Again, that vertical change over the horizontal change. Number 2, find the slope of a wooden wheelchair ramp that rises 2 inches, so that's going to go on top, for every horizontal change of 24 inches. So that's going to be 2 over 24, because again, that's rise over run or vertical change over horizontal change. That simplifies to 1/12. We'll often keep our slope as a fraction. Even if it's a mix or it's an improper fraction, we'll keep it as an improper fraction rather than writing it as a mixed number, like when we did ratios and unit rates. But we can sometimes also see slope written as percentages, like I said, when we talk about the percent grade of a hill or on the side of a mountain, for example. If you're going on a hike would be another example you might see that. All right, let's take a look at finding slope graphically. So the first example here, we have a line. Keep in mind that slope is rise over run, so how far we go up or down over how far we go left or right. So we go from one point to the other. And to get from, I usually go from the point on the left to the point on the right, but you could go from the point on the right to the point on the left as well. But I always do up or down first and then left or right second. So to get from this point on the left to this point on the right, I'm going to go down 3 units, and my rise is going to go on the top. So down 3 is going to go on the top, and then I'm going to go right 1, so that's going to go on the bottom. So we've got our down 3 on the top, our vertical change, over our horizontal change, which is right 1. Down 3 is a negative value, so we can represent that as -3. Right 1 is a positive value, so we can represent that as +1. -3 over 1 simplifies as -3. Like we mentioned in a previous lesson, since this line goes down from left to right, it makes sense that it has a negative slope. And the larger that value is, or the absolute value of that number is, the steeper the line will be. So if that were a slope of -3, this would be even more steep than it already is. If, let's say, it had a slope of -1, it would be less steep. Let's take a look at example 2. So to go from the point on the left to the point on the right, I have to go up 1 unit. So up 1 is going to go on the top. That's our vertical change. And I have to go right 4 units. 1, 2, 3, 4 units. So right 4 is going to go on the bottom. Up 1 is a positive 1, right 4 is positive 4, so our slope is 1/4. Notice how this line is less steep, so it has a smaller slope, in fact a fractional slope, which makes sense here. Now I do want to point out again, you could have gone from the point on the right to the point on the left. That would be down 1 unit, which is -1, and to the left 4 units, which is -4. And -1 over -4 is also equivalent to positive 1/4. So you still get the same slope even if you go down 1 and left 4. You just get 2 negatives, which makes a positive. All right, let's take a look at a couple of examples. So number 3, I'm going to go from the point on the left to the point on the right, and I'm going to go down 1 unit, and I am going to go to the right 1, 2, 3, 4 units. So down 1, right 4. Down 1 we can represent as -1, right 4 we can represent as positive 4. So the slope is -1/4. Now that negative I have on the top of the fraction, it can go right in the middle. If you had gone up 1 and left 4, you might have 1 over -4. Either way, that's a slope of -1/4, and this line goes down from left to right, so it should have a negative slope, which it does. All right, let's take a look at number 4. So I'm going to go from the point on the left to the point on the right, and I'm always going to do my vertical change first. So I'm going to go up 3 units, and I'm going to go right 1 unit. Sorry that my yellow line got messed up there. But that is going to, just erase that. That is going to be up 3 and right 1, which is positive 3 over positive 1, which is a slope of 3. And that makes sense since it goes up from left to right. All right, let's take a look at number 5. So I'm going to go from the point on the left to the point on the right. So I'm going to go down. Let's count how many units. 1, 2, 3, 4 units. And I'm going to go to the right. 1, 2, 3, 4, 5 units. So down 4, right 5. That's going to be -4 over 5. So a slope of -4/5. Now pay attention to number 6 because this one is counting by 2s. So I'm going to go up, vertical change, and then I'm going to go to the right. So I'm going to go up, let's see, 1 and then another 2 units, which is up 3. And then I'm going to go to the right 1, another 2, which is 3, another 1, which is 4. So I'm going to go up 3, right 4. Both are positives, so that is a slope of 3/4. All right, number 7. If we take a look at a horizontal line, what we notice is that to get from one point to the other, we go up or down 0. And we go to the right or left 7 units. So the slope of this line is 0 over 7, and 0 divided by anything is 0. That makes sense. If we're talking about the steepness of a line and it's a horizontal line, it doesn't have any steepness. It's flat. So it's like walking on a flat surface, or if you have your treadmill set at 0 so that you're not going up or down, then that's going to be a steepness or a slope of 0. Number 8. So for this one, it's a vertical line, and we go left or right 0, but we have to go down 5 or up 5. It doesn't matter whether it's up or down 5, but 5, your vertical change is going to go on the top, and then your horizontal change, which is nothing since you don't go left or right at all, of 0 goes on the bottom. You cannot divide by 0, so we say that the slope of a vertical line is undefined, which makes sense because it's so steep it doesn't have any sort of way to define it. It actually approaches infinity. So we say that we really cannot define the steepness. Like some of those roller coasters at some of those big amusement parks, right? They're so steep, they go straight down. That slope is undefined. I want to quickly remind you that we will leave slope as a fraction or improper fraction in simplest form. That's important for us, just like when we used unit rates and ratios earlier this school year. All right, let's take a look at finding the slope of a line that passes through 2 points. So usually what I'll do is I'll list those points vertically. So 5, 5 and 4, -2. We don't need the C and the D there at all. That's just a way to name the points. Now keep in mind we want to subtract the Y's and put that on the top. And we can do that in any order. I chose to do 5 minus -2, so I did top to bottom, which means that when I subtract the X's, I have to do 5 minus 4. I can't do 5 minus -2 and then put 4 minus 5 on the bottom because I have to start at the same point. So 5 minus -2 is equivalent to 5 plus 2. Keep my 5 minus 4 the way it is. 5 plus 2 is 7. 5 minus 4 is 1. Our slope is 7 over 1, which is a slope of 7. So this would be a really steep line. Let's look at number 11. We have 8, -3 and 11, 2. Subtract the Y's and put that on top. I chose to do 2 minus -3 on the top, which means on the bottom I have to do 11 minus 8. 2 minus -3 is 2 plus 3, or 5, and 11 minus 8 is 3. So that slope is 5/3. Notice how I kept it as an improper fraction. All right, moving right ahead to number 12. So we have 5, -9 and 0, -12. So I chose to do -9 minus -12 on the top. Remember, put those Y's on the top. The biggest mistake I see is students accidentally put the X's on the top. So that means I have to do 5 minus 0 on the bottom. That's -9 plus 12. Once I add the opposite, 5 minus 0 on the bottom, that ends up getting us a slope of 3/5. All right, number 13, we've got -4, -6, and 5, 3. So I'm just going to subtract the Y's and put that on the top. I did 3 minus -6. So on the bottom, I'll do 5 minus -4. That's 3 plus 6 and 5 plus 4 once I add the opposite. That gets me 9 over 9. And when I simplify that, that's a slope of 1. All right, let's take a look at number 14. This question's done for us. You notice that when I subtract the Y's, -2 minus 3 gets me -5, and -5 minus -5 gets me 0. Remember, when 0's in the denominator, we say that's undefined because these points, if we graph them, would be right on top of one another, so it would form a vertical line, which is undefined. So you can guess probably that number 15 is going to be the same. We're going to take -2 minus -8 on the top, which is -2 plus 8, 6 minus 6 on the bottom. We end up getting 6 over 0. Again, if you have 0 in the denominator, we say that that slope is undefined. So you can probably guess that number 16 and 17 are going to have slopes of 0. Because if I take -2 minus -2, I get 0 on the top. And if I take 4 minus -5 on the bottom, which is 4 plus 5, I get 9. 0 divided by anything is 0, so our slope is 0. Let's take a look at number 17. So our Y's are both 8. So we'll take 8 minus 8 on the top and -3 minus -5 on the bottom. That gets a 0 on the top and -3 plus 5 on the bottom, which is 2. No matter what that denominator is, we are going to end up getting a slope of 0. So that would be a horizontal line. All right, let's talk about slope and just summarize this a little bit. So if we have a vertical line, keep in mind our slope is going to be undefined. And if we have a horizontal line, our slope is going to be 0. Don't forget, a positive slope, or a line with a positive slope, is going to go up from left to right. A line with a negative slope is going to go down from left to right. It says, can you give an example of a graph that does not have a constant slope? So this would be something that's zigzag or curved. So if I had something that was, I'm just going to kind of freehand this. If we had something that was curved sort of like this, this doesn't have a constant slope. It's steeper, and then it slows down, and then it becomes negative, and then it becomes positive again. If we had, again, something that's a zigzag, that would also not have a constant slope. When we talked about proportional versus non-proportional, we saw some non-proportional relationships are zigzags or curves. All right, number 18. A family camping in a national forest builds a temporary shelter with a tarp and a 4-foot pole. The bottom of the pole is even with the ground, and one corner is staked 5 feet from the bottom of the pole. What is the slope of the tarp from the corner to the top of the pole? So we've got a 4-foot pole, and this red tarp that we have here is going to be staked 5 feet from the bottom of the pole. So if we do rise over run, or vertical change over horizontal change, this is going to be 4 feet over 5 feet, which is a slope of 4/5. Number 19, a rectangular painting on a gallery wall measures 7 meters high and 4 meters wide. What is the slope from the upper left-hand corner to the lower right-hand corner? So this one's going to have a negative slope. So we've got a vertical change of -7 and a horizontal change of 4. That's going to be -7/4. Again, if we were going from this bottom right corner to top left, that would be a little bit different. We could end up with a positive slope. And here it doesn't really matter whether it's a positive or negative slope. It's just going to be 7/4 in this case. We're not going to have any word problems in any sort of quiz or test, but I do want to have just, again, a very minor introduction to slope. All right, number 20. Two highway routes connect City A to City B. The first route rises 4 yards vertically for every 30-mile stretch. The second route rises 8 yards for every 70-mile stretch. Which statement is true? Well, let's compare the slopes here. So we've got our first route, which has a slope of 4/30. That reduces to 2/15, and I wrote them as decimals because I think decimals are easier to compare. That's 0.13 with the 3 repeating. The second route is 8/70, which reduces to 4/35, and as a decimal that's 0.114. So if we're looking at comparing those two decimals, the first route is going to be slightly larger at 0.13 versus the 0.11 for the second route. So that first route is going to be slightly steeper than the second route, so that would be choice A. They do have fairly similar steepnesses, so C is pretty close here, but they're not exactly the same. City A to City B, that first route, is going to be just slightly steeper. All right, number 21. A home builder has 4 models with roofs having the dimensions in the table. Which roof is the steepest? So I did 5/15 for roof A, and that got us 1/3 or 0.3 repeating. Roof B was 4/16, which is 1/4 or 0.25. So far roof A is steeper. Then I did roof C, which is 10/20 or 1/2. That's 0.5. So that is actually the largest so far. And finally, roof D is 14/21, which is 2/3 or 0.6 repeating. That does have the highest value. So we could say that roof D would be our winner here, and that is because it has the highest slope. So we can say roof D has the highest slope. And I showed the work to prove that. I know it says to explain, but we're just doing the bare minimum or basics here with slope at this point. You'll get into this more in depth next year for sure. All right, let's go ahead and take a look at our last question. Andrea and Ben found the slope of the line that passes through -8, 2 and 4, 0. Who is correct? Well, Andrea did -8 minus 4 on the top, 2 minus 0 on the bottom. She simplified and got a slope of -6. Ben did 2 minus 0 on the top, -8 minus 4 on the bottom to get a slope of -1/6. So these are really similar, but not exactly the same. So what we notice here is that Ben chose to put the y's on the top. Well, didn't choose, but he did put the y's on the top. 2 and 0 are the y coordinates, and -8 and 4 are the x coordinates. So Ben is correct. We can say that he subtracted the y coordinates and put those on the top, which makes his slope correct. Andrea, accidentally, a common mistake that students make, put the x's on the top, and that's going to get us the inverse of the slope that we want. So definite, well, the reciprocal, I guess I should say, the reciprocal of the slope that we actually want. So Ben is correct here since he subtracted the y coordinates and put those on the top. All right, really the basics of what you need to know for slope this year, since we just introduced it, is first looking at it graphically, understanding that slope represents the steepness of the line, certainly important for us. And then the other thing to be familiar with here is finding slope from 2 points, subtracting those y's, putting it on the top, subtracting the x's and putting those on the bottom, and then simplifying that slope in the end. Thanks for listening. Final set of guided notes for the year. Have a great summer.